This will be lesson 1 of unit 2, so lecture 2.1. In this unit we'll talk about matter and its properties. So here is where we're going to get a little more into chemistry. So matter will be the discussion of the chapter. Let's go ahead and define matter. Matter will be defined, there are really two parts to the definition of what matter is. And it has to have mass, and it has to take up space. So really mass and volume. So anything that has mass, now sometimes it's tough to measure the mass of something. Air, for example, the question here is air matter? Air has mass. We can actually weigh air. It's a bit strange, but we can fill a bottle with air and weigh it, and then take the air out, and the bottle will weigh less. So air is definitely matter. Air also takes up space. Even though we can move through it, if we were to place it, say, in a container, we can definitely see that it takes up the space in that container. Now, many things that are not matter, heat, or really any form of energy, is not considered matter. So light, for example, sound. Information is another thing that's very important, but that it is not matter. Information, you know, if you have a CD with a music recorded on it, that is real stuff, but the CD does not weigh anymore because it has it on there. So matter is what we'll be discussing, and we'll definitely be discussing these two properties, mass and volume. And in fact, we're going to do just that with density. So you probably have heard of density, hopefully before, but the question we're going to discuss quickly, and then we'll do some calculations using density, is what is density? Now, here we have two spheres. This is a smaller sphere, and this is a bigger sphere. Both of them are actually made of steel. Now, this one, down at the bottom, if you put it into the water, it will sink to the bottom really quickly. The top one actually floats. Now, the difference between them is they have the same mass, so mass is the same. Mass is equal in both of them. However, one of them has a much bigger volume. So because this one has a much bigger volume, it is able to float. And you can think of it kind of like in the picture on the right. This top solid, rectangular solid, has the particles, we'll say these are the metal atoms, are much more spread out. So they don't take up as much space. On the bottom one, they're much more compressed, closer together. So because the mass is closer together in the bottom one, it is more dense. Because it is more spread out in the top one, it is less dense. So you can think of the particles in this sphere as much more spread out, further apart from each other, which makes it less dense, makes it float in water. And we'll discuss this idea of density a little more. Now, in truth, the sphere is actually hollow on the inside, but the effect is the same as if the matter, the atoms, were more spread out. Let's go ahead and give the definition for density. And the definition is mass divided by volume. Very commonly, we represent it like this, as D equals M over V. Now, it's important to be able to rearrange the equation to solve for either the mass or the volume. You would have learned this in math or in algebra. So since our initial equation is density equals mass over volume, if I have to solve for mass, I have to rearrange the equation to solve for mass. I will get rid of volume, and I will put volume on this side. This is legal in math because in order to undo something, you would do the opposite. So I will multiply by volume to get rid of volume. I must also do the same thing on the left side. The volumes cancel out. My equation says mass equals volume times density. So here's the second equation derived. And then I can derive a third equation by solving for volume. In order to solve for volume, I would move then density over to the other side. Again, because it is being multiplied, I would divide by density. If I divide it here, I have to divide it on the left side. I end up with my third equation, which says volume is mass over density. So here's the third equation. So really, you've got these three equations that you're dealing with. Density is mass over volume. Mass is volume times density, and volume is mass over density. We'll use all three of these. So, real quick, here are some common densities of different materials. You can see that water has a density of 1, And you probably know this, that anything that is less dense than water will float, anything more dense will sink. So, for example, cooking oil, you may know that oil usually floats on top of water. You can actually set up a layer of liquid oil over some water. And then the more dense you are, say for example, a metal like zinc will sink in the water. This is true. So water has a density of 1.00. It's been defined as 1.00. Now here we have a picture of another liquid. This is liquid mercury with a density of 13.6. And then we have a copper or a little brass, which is mostly made of copper, a little weight, whose density is 8.9. And notice that the brass weight, the copper weight, actually floats in the mercury, which is pretty strange, but that's because the copper is less dense than the mercury. So you can do this with really any material. And let's go ahead and give you some actual units for density. If you're dealing with a liquid, usually the units are represented as grams per milliliter. If it's a solid, it's per centimeter cubed, but the centimeter cubed and the milliliter are actually the same, as you see here. They're equivalent. It's just that it's easier to measure solids using centimeters cubed because you can measure each side, the centimeter, and then multiply them together. And with volumes, or with liquids, you usually use a cylinder of sorts to measure them. And then gases are usually grams per liter. That's because gases are much more expanded. They take up much more space, so we will use liters instead of milliliters. Let's go ahead and do a few problems. This one says if 12.9 grams of aluminum has a volume of 4.8 centimeters cubed, what is the density of aluminum? So what we're essentially doing here is we're applying the density equation. And remember, the density equation says density is mass over volume. In this case, we're given the mass as 12.9 grams. So we'll put that on top, 12.9 grams. We're given the volume as 4.8 centimeters cubed. And notice that aluminum is a solid, so we're giving it in centimeters cubed. We'll divide that by 4.8 centimeters cubed. Now just dividing these two numbers, go ahead and do this in your calculator, should give you an answer of 2.6875. We have to follow significant figure rules. So the least is two numbers, so we'll only put two numbers. In other words, we'll put 2.7. The units for this one, it's also important to put the right units, will actually be both grams and centimeters cubed. So grams per centimeters cubed, or cubic centimeter is the other way of saying it. So we've got the density of aluminum. Notice aluminum is not very dense compared to other metals. It's actually one of the less dense metals, very light metal. Let's try this example here. The density of mercury is 13.53 grams per mil. Notice it's a liquid, so it's given as milliliters. And what is the mass of a sample of mercury if you have 25 milliliters of it? Here we have to solve for the mass. Remember, our initial equation is density is mass over volume. In order to solve for mass, we would move volume over this way to multiply it. So we end up having our equation say mass equals volume times density. And that's exactly what we'll do to get our mass. Let's take our volume, which is 25 milliliters, and multiply it by our density, which is 13.53. And the units are grams per milliliter. So we're just multiplying these two numbers. Go ahead and do this in your calculator. You should get an answer that's 338.25. Looking at the significant figures, again, we have 2 for the least, so we have to round this to 2 sig figs. Remember, in order to do this, we have to make this 8 into a 0, but when that happens, this 3 becomes a 4. So we have 340. Now how about the units? Since we're solving for mass, the units should be grams. And in fact, these milliliters will cancel out with these milliliters because they're on opposite sides and leave us with grams. So we put grams. Do not put the decimal place there, as that will make the 0 significant. In this case, we have 340 grams of mercury in 25 milliliters, which 25 milliliters is not a lot, and 340 grams is a third of a kilo. That's quite a bit. That's because mercury is extremely dense. Let's go ahead and do this last problem. In this case, we have iron, whose density is 7.87 grams per mil. And how much volume will 55 grams of iron occupy? In this case, we're back to the equation. Remember, our equation is density is mass over volume. If we rearrange this equation to solve, in this case, for volume, I'll end up moving volume out here, and then I'll end up moving density down here. This is just by algebraic rules, rearranging the equation. And my new equation is volume is mass over density. If you have trouble rearranging equations like this, talk to me, and we can actually help you do a little bit of the background algebra for this. So we have dividing mass over density to get the volume. Our mass, in this case, is 55 grams. Our density is 7.87. 7.87 grams per milliliter. So go ahead and calculate this out on your calculator. The answer you get should be 6.98856. Again, following significant figure rules, our least is 2. Remember, with division and multiplication, we go by the least. So we'll have to get this down to 2. Now, in order to get this to 2, we have to cut it off right here. And this 9 will get rounded up to 0, which will round up the 6 up to a 7. So really, we have 7.0 for our answer. The units in this case, since we're solving for volume, it should be in milliliters, because the grams will cancel out, leaving us only milliliters. So 7.0 milliliters. You can also say 7.0 centimeters cubed, since we are dealing with a solid. Iron is a solid, and this would be how much volume is contained in 55 grams. Hopefully these examples weren't too difficult. Go ahead and try this one on your own in your notes, and then we'll talk about this and we'll wrap it up in class.